Okay, this PowerPoint will cover section 3.3, which is really from last week, kind of bundled in with the test. 3.4 and 3.5. Now, I'm not really going to talk much about all of the topics that are in the slides. The slides pretty much cover everything, but I will slow down a bit and talk about the slides where students tend to ask questions. All right? So, heading on, so 3.3 comes first. Basic functions and piecewise functions. Now, the basic functions thing is they're going to give you 10 basic functions that they think you should know. So like this one's a constant function. If they say f of x equals a number, then you're supposed to know it's a straight line, horizontal line like that. All right, and f of x equals x is the y equals x line like that. F of x equals x squared is the parabola, right, the cubic. This is the absolute value function, okay, the square root function goes like that. The cube root goes like this. It really looks like the cubic one turned on its side and smooshed a little bit maybe, right? There's the square root, the cube root function. The reciprocal function, okay? So 1 over x here looks like this. It's split. It has a vertical asymptote on the y-axis, right? The greatest integer function, fortunately we don't use this one very much, but it's in there a couple of times, okay? So it's the double bars on both sides. So what happens is, if you look here, you have these stair steps that are not connected, right? So if x is between 0 and 1, the greatest integer is 0. Once you get to 1, so really there's a, this graph doesn't show it very well, but there's an open circle at the end of each one. Okay, because when you get to the next whole integer, it pops up. So at 1, it pops up to this one. Anywhere between 1 and 2, it's 1. When you get to 2, it pops up to this one. Anywhere between 2 and 3, it's 2, etc. Right? When you get to 3, it pops up to this one. That's the way that one works. Now, this piecewise defined functions, there are a bunch of them that are like this. And so you really need to learn how this works. Okay, so what's going to happen here? We have f of x equals, and then you get this curly bracket. Okay, so in this case, there's two pieces to it. That's why they call it piecewise. If x is less than or equal to 1, then this is the function, 2x minus 1. If x is greater than 1, here's the function over here, x plus 2. Okay, so let's have a look. X is less than or equal to 1. Right? So let's do something here. So or equal to 1. So if x is 1, so x and f. If x is 1, right, then you stick 1 in here, you get 2 minus 1 equals 1. If x is 0, you get 0 minus 1 equals minus 1, right? If x is minus 1, you get minus 2 minus 1 equals minus 3. Okay, so if you're at less than 1, here's your x equals 1, x equals 1, f equals 1, that's this point, right? X equals 0, f equals minus 1, that's this guy right here, this point right here. X equals 1, f equals minus 3, that's this guy here, right? So you see these 3 points here, all right? These 3 points are on that line, and it goes down. Now, what if x, though, is bigger than 1? Well, you can go ahead and put in the middle point. At 1, this thing is going to be 1 plus 2 equals 3. Now 1 is not on here, you'll notice that, right? So to make a note to myself, I'll circle that one. That one means that's the open circle point, right? There's the open circle point. What if you go up? What if x is 3? Well, here's the function. 3 plus 2 equals 5, all right? So at 3, boom, 5, there you are, right? So we have two pieces to this graph. When x is less than or equal to 1, you graph it, right, like down there, like it's 2x minus 1. That's using just your normal line plotting. The only thing that's different is the biggest x can be on this is 1, right? If x is greater than 1, then you use this one. Normal line plotting, right? Stick in x is 1 and x is 3. get 3 and 5, so you get 1, 3 and 3, 5, and you get this line right here. Okay. So the thing you have to be careful of, because the new piece here, is instead of just getting one function, these functions, they're called piecewise because they have separate pieces that are put together on one graph or into one function. And they tell you the pieces. The pieces are here. In this case, one piece is when x is less than or equal to 1, and the other piece is when x is greater than 1. And then you can graph each piece separately. You just have to make sure to stop it where they tell you it stops, right? This lower piece stops when x equals 1. There it stops. This upper piece starts when x is 1, right? Except the 1 itself is not included, so we get the open bracket, and then it goes on. Okay? So, let's just plot a few points on this one. So, let's find f of minus 2. Well, in this case, what are our two pieces? Our two pieces are less than or equal to 1 and greater than 1, right? Minus 2 is less than or equal to 1, so it'll be in this one. 2 times minus 2 minus 1. Whoops. That is minus 5. What about 5? Well, 5 is definitely greater than 1, so that's going to be 5 plus 2 equals 7, right? So this one was f of minus 2. This one is f of 5. What about f of 1? Well, f of 1 is right on the dividing line, right? But here's the or equal to, so the 1 falls in this one. So we do 2 times 1 minus 1 equals 1. There is f of 1. All right? So again, you got two pieces. They define them for you here, and you just have to use the definition. Minus 2 is less than or equal to 1, so it uses the first piece. 1 is also less than or equal to 1, so it uses the first piece. But 5 was greater than 1, so it used the second piece. All right, so that spells that out there. Now graphing it, you just plot the points you've graphed. Okay? And so you plot the two different pieces on the same graph. That's really all you're doing. You just have to, that's the new thing about the piecewise is there's more than one piece. Some of them will have three pieces. Okay? You just plot the separate pieces on the graph, and then if there's anything you got to be careful of is when they say one of the pieces stops at 1, then you have to, when you draw the graph, you got to stop it at 1. Before now, when you're graphing stuff, things go on forever in both directions, right? But now that you've got these pieces, the pieces only run where they tell you, right? In this case, this top piece only runs when x is less than or equal to 1. So that's how when you graph it, you get this thing here, right? And you notice it ends right at 1 because it stops there at 1. The top piece is only greater than 1, right? So you'll notice it also stops at 1 and goes on to the right. Okay? You just got to be careful to follow those. When they tell you where a piece is, you got to be careful and follow it. All right, so I rarely get many questions about the even and odd, so I'm just going to skip over that. It's in there, though.